The topic today is data integration for conservation science. And I will play something for you, and then you know what the talk is here.
Anupam, that certainly woke us all up.
I
think we're now ready for Catherine.
It's the time to disco, Catherine, so the floor is yours.
All right. Well, hopefully I'm sharing my screen now. Does everyone see that?
Yes.
Yes. Okay, great. As Anupam said, my name is Catherine Patterson, and I'm a conservation scientist at the Getty Conservation Institute. And I'll be talking to you today about, yes, a project we call Disco at the Data, or at the GCI, to help us dance better with our data. But for your purposes today, we'll be referring to this as Arches for Science, and I'll explain that a little bit later on. I also have with me on the call today my colleague Dennis Wuthrich, and he comes at this from the technology side. He's the person who actually helps build the softwares that we're going to talk about today, which itself should provide you an overview of what's so important. And before we go any further than this, I also would just want to pause for a hot second and say, with everything that is going on in India right now between COVID and cyclones and everything else, we really do appreciate the opportunity to tell you a little bit about what we've been doing to try and extend the Arch platform that you heard about last week into something that works for folks like me, that is practicing conservation scientists. Hopefully the slide advances here. There we go. So I know that you've been learning quite a lot or hearing quite a lot about what conservation science can look like in a museum type of environment, which is the environment that I work in. But just to make sure we're all on the same page, I kind of want to come at this from a sort of high level view, and we'll progressively dive in and get a little more specific and get a little more detailed about what a technical data integration system for science or for conservation science might look like. So just to kind of recap the process of technical analysis, and I will say, since I work in museum environment, very often I will use conservation science and technical analysis interchangeably. And what I mean by that is the process by which I'm typically asked to look at one or a body of objects, often in my case, movable objects, although it doesn't require that they be movable, and such as the grouping of images that you see on the screen here. This happens to be a collection of illuminated manuscripts or painted books and panel paintings that are all produced in a single 14th century workshop in Florence, in Italy. And as a conservation scientist, we are asked to take objects that look like this and answer questions about them through some sort of scientific observation. The types of questions that we may be asked to address are, as I'm sure you've heard over the course of your workshops, incredibly broad. We can be asked to talk, for example, about what conservation treatments might be appropriate for an object or a set of objects. Can we be more specific about attributing particular works of art to particular artists or artist workshop? We may be asked to talk about date or to understand the change of an object over time. There's a huge breadth of questions we may be asked to answer. Just for a little bit of context, in this particular instance, the question that we were addressing was one about workshop practice. So all of the objects that I'm showing you on the screen were produced by the same Florentine workshop, which might seem like somewhat strange. Why would one workshop produce both books and panel paintings? And that was a curator's question, is what could we learn by studying the materials in these about how one workshop would have worked in the two different modes, books and panel. So as I said, to do any kind of study like that, as a scientist, I come at that from the point of view of collecting data. So here you see 3 images, 3 action shots of data collection on some of those objects that you saw on the previous slide. What I want to point out here is that the way we collect that data just like the questions we try and answer, is incredibly broad, incredibly variable. And so, for example, what you may be able to work in situations like you see in the left image, where I'm in a very controlled environment using a benchtop, in this case, Raman spectrometer in the GCI laboratories, where I have complete control over everything that's going on. If we look at the far right picture, sometimes we have a very different situation where I'm in a controlled environment, say the gallery at the museum, but being asked to very briefly, in a very small amount of time, analyze an object, in this case, while it was being deinstalled. So I had something on the order of 12 minutes to look at this object between when it came out of its case and when it went into its packing crate, right? And that necessitated the use of, as you can see in my hand, portable instrumentation to take a particular measurement. And then, of course, we sometimes have situations that are somewhat less controlled, as you see in the image in the center, where, for example, we're actually taking our scientific technologies to the field, working in this case, a chapel in Florence, collecting data while the painting still hangs on the wall, again, using portable instrumentation. So lots of environments, lots of instruments, but all of them result in some form of data. So I'm just showing you here representative spectra that come from each of those 3 data collection modalities. What we do then as scientists is we take all of that data, whatever it looks like, and from however many objects it was gathered from, and our job is to do some sort of synthetic analytical work to collapse all of that information into an understanding of the objects. In this case, I'm sort of showing you one of the ways that that played out for this particular work, which was done, I should note, for a specific museum exhibition called Florence at the Dawn of the Renaissance, Painting and Illumination from 1300 to 1350, which took place in about 2012. And what we did for this is all of the information I learned from about 30 different objects had to be understood as a unit, where I built this table that was in the exhibition that shared with visitors, for example, what were the materials that we found in panel paintings, and compared that to what were the materials we found in manuscripts, what materials were found in both, and what did that tell us about workshop practice. So hopefully, just the fact that I'm able to show you that didactic should tell you that clearly conservation scientists, this is the work we do, and you know, we've been doing it for decades. Most people know what they're doing and how to do it. So the question I hope you're asking is, why do we want to introduce a technology solution into that process that already works in terms of creating new knowledge? It's fortuitous that we're having this conversation now in the time of COVID, when it's been made more clear to all of us than it ever has been before, just how collaborative this kind of work is. So I'm showing you here on the left, for example, an image of 2 curators, one who works at an institution in the UK, one who used to work at the Getty and was part of this exhibition, actually standing in front of a light box and trying to understand what X-ray images of the manuscripts taught us about those objects. So we bring people together, we bring data from a bunch of different objects together, and we understand it through a collaborative discussion type of modality. That's a lot harder to do if you can't meet in person. So it would be really nice to be able to recreate that collaborative research environment in a more digital function. And as I said, COVID has made that more clear than ever before, that we need mechanisms to do this. The other reason we might be interested in technology has to do with the sheer volume of data. So I might have just mentioned offhandedly that this particular exhibition, I looked at something like 30 objects. So I'm showing you here just one of them, Leaf of the Martyrdom of St. Lawrence. And from just this one object, I went ahead and counted it up, and it looks like I took about 450 individual pieces of data, about 300 images, and those images ranged from images of the whole paint, all the way down to individual images taken from the instruments that we work with that showed individual pigment particles, for example. And all of those spectra and images came from about 14 different sources, instruments, cameras, that kind of thing. So that's just a huge volume of data. And if you were to go to my office right now and see how that data is stored, you'll find what I imagine you'll find at each of your desks, you know, a set of file folders labeled in ways that make sense to me. But in order to find any individual spectrum of that 447 spectra that I took, you have to know where to look in my file cabinet. And so wouldn't it be nice if we could render this huge volume of data more easily searchable and more easily shareable? And then coming from a pure data and data science perspective, the other thing that it occurs to us is that if that data were searchable, that would enable more complex data analysis, sort of data science kinds of approaches to the data, as well as making sure that other people could find it, whether or not you know what my file cabinets look like. So all of these sound like things I hope that technologies of various sorts can help us with, and it's why I, at least as an individual, began to be interested in understanding whether there was a technology solution to some of my technical analysis questions. But first things first, those of you who were at Dennis's talk last week, Dennis and Annabelle's talk last week, heard them say several times that one of the important things to do is to make sure before you try and use or build a technology solution for your problems, that you really understand your problems and build towards the questions you have. And we wanted to make sure that was true in this milieu as well. So one of the first things we did was undertake a series of visits to other individuals or organizations that do cultural heritage research, located mostly in the East Coast of the US and Europe, mostly for ease of travel reasons. But basically what we wanted to do was go to these organizations and talk to people who do technical analysis research and try and understand what their problems actually were, and to understand whether what I saw in my work represented what we saw in the field. We did that through these interviews that we called use case research interviews. You can see on the map on the screen some of the places we went in these different places. But basically what I want to kind of communicate here is that we tried to visit institutions that use a small number of visits to get a broad sense of the field. So we visited both quite large, sort of national level museums or archives. We visited small institutions, which might have very different takes on what's required. We visited organizations that were had connections to their local governments and ones that were privately run. We talked to museums, we talked to libraries, we talked to organizations that had a high technology sort of baseline and ones that had a low one. And we talked to people who work with very different types of data, whether that was imaging, spectroscopy, the kinds of materials they studied. And basically we were trying to get a really broad view of what the questions that people had and what would be most important to them in any kind of technology solution. So what did we learn from those interviews? Well, sort of starting at the top, like if you have data from objects, what do you want to do with it? We found out that that's probably the most consistent between organizations. Everyone is very interested in taking objects, whether one or more, like you see two of the illuminated manuscripts we've been discussing in the corner. They want to be able to find connections between those objects. They want to be able to understand what materials are present in each of these manuscripts, regardless of which instruments we had available to study them, for example. We want to be able to study how these objects are changing over time, or how our knowledge about them is changing over time. So the kinds of uses that people want to make of their data are pretty consistent among organizations. In terms of the actual data themselves then, we also learned that one of the things that's really important to people is that they want to be able to have access to the spectroscopy. They don't just want a system that tells them in words, in language, what this particular Raman spectrum showed. They actually want to see the Raman spectrum. They want to be able to examine that spectrum for themselves. They're also interested in comparing spectra. So to look at, for example, both the Raman and the FTIR spectrum from the same area. But in addition to the data themselves, they really want to understand, and they think it's critical to know the context in which that data was taken. So for example, it's not enough to just have access to the two spectra you see on the screen. You need to know that they both come from this little area that's marked by the red box. So that spot map is really important, for example. So basically understanding the context in terms of where data came from, why it was taken might give you information about why the spectrum looks the way it does, for example. And people really want to understand that in order to maintain the fact, or to keep the data interpretable over time, in short. The other thing we learned is that people have a lot of concerns around data access and sharing. That is, there's a strong recognition that not every piece of data that a conservation scientist takes about an object is going to be available for the same level of sharing. There's kind of a wide recognition that there's some information that people might be very happy to share with not just all of their colleagues, but even, for example, the general public. Things like photos or contact information of who to contact if you have information or you want more information about a project. There's also other types of information for which they might want to allow only selective access. Like maybe you don't want everyone, maybe you don't want the general public to be able to see your individual spectral data, for example. And maybe there's some information that's actually really quite sensitive, like how you treated something. Maybe the actual uninterpreted data that you took. Maybe you don't want to be able to share that at all. And that some of this may be defined not by the scientist who took the data, but by, for example, the owner or manager of an object or an institution. So people had quite a bit of concern about that. One of the other things that came up quite a lot in these interviews is we asked people if all of these sort of issues around data use, data access, data analysis, and interpretation are so common among different organizations, why don't they do this in a digital platform already? And to make a complicated story very simple, we learned, if the slide advances, there we go, that one of the main things that's keeping this from happening has a lot to do with data organization and management. In short, we learned that I'm not the only person who has a kind of messy file drawer with a file organization structure that makes sense only to me. You know, we all have our ways of organizing our little cabinets or the sort of digital representations of those, whether that's on your personal computer or on a server at your institution. We all kind of do that differently. And one of the things that people really commented on is that that esoteric data management that we all have is one of the primary barriers to even simple data sharing, for example, within your own organization. It is true that a lot of my data is stored on my laptop, and if I don't come in one day and my boss needs a piece of data, she may not have access to it. So the fact that we organize and manage our data the way we do has sort of big implications in terms of how effectively and easily it can be shared and reused, even within an organization, let alone outside of it. That said, people understand, as a general rule, that having a more uniform way of organizing data and a way that makes it shareable would enhance not only our ability to find data, but to reuse it, and to avoid institutional information loss when data becomes inaccessible. So people understand that that would be useful, but we found that a lot of organizations didn't really have the capability to build something that would meet all these needs themselves. And so as we heard that, that's where the project at the Getty really started to take shape. Was we realized that there was a real need in the field for a system of some sort that would help conservation scientists manage their data in a way that would keep it secure, that would allow us to retrieve it when we needed it, that would allow us to compare information, share it with our peers, all of that kind of work. In short, we realized that we could be useful in building the bottom tier of this pyramid of sort of data and data analysis that I just showed. And if we can build it, we're hopeful we can share that tool with the rest of the field. Now here I will kind of back up to the video that started us out today. You will occasionally hear me say DISCO versus Arches for Science. And I just want to mention that what we mean when we say we need to build something, we do want to build something that I can use. And the version of it that I will be using at the GCI, we're calling DISCO. But the version of it that we can make freely available to labs worldwide, that's Arches for Science. So I want you to think of this as Arches for Science, and please forgive me if I slip and say DISCO. We mean the same thing for the purposes of today's talk. So hopefully that gives you a sense of what the overall project is. It's to build this data management platform, which I'm sure sounds fabulous in theory. But now I want to start diving in a little bit deeper and say, okay, well, what would that mean? What would it mean, or what would you need to be able to do to organize and manage the data from a typical conservation science project? And in this case, I am going to use the technical analysis of an object as a description. And so one way to do that is to figure out how to categorize the parts of a technical analysis project in such a way that a computer could be used to manage the data. So we'll start with an analysis that I did relatively recently of the painting that you see on your screen here at left. This is Jean or Spring by the artist Manet, Edouard Manet. And we analyzed this again for an upcoming show. Now, if I ask you to sort of categorize this item that you're seeing on the screen, you might say, well, it's a thing, it's a painting, it's a physical painting that exists in the world. And that is one way you could organize it. The other way you could organize it is by knowing that it's actually one of two paintings that we analyzed for this exhibition. That is, it's one physical thing in a collection of paintings by Manet that we analyzed. Another, to get a broader view of the project, you would probably have to know that I did quite a lot of the work. So you see me pictured here looking at the painting under the microscope, but I didn't do it by myself. I did it with my colleague, Debbie Ormond, who's a conservator who was working on this painting. Each of us are people, but together we are the Manet Research Group. So that's one way you could categorize this important component of the project. What did Debbie and I do? Well, we took a lot of data. So we went to instruments like the macro X-ray fluorescence scanner you see an image of here. We collected data and made observations about the painting through that mechanism of scientific analysis. The other thing we did that's very common in this kind of work is we actually removed small samples from the painting and looked at them as cross-sections, which you see imaged here. So we actually went through a very specific kind of activity known as sampling, and through that sampling created a secondary little piece of physical material in the world, this cross-section that is, of course, related to the painting from which it came, but which you might want to track differently than the painting itself. From both the sort of experiments that we do non-invasively and the samples, we collect a bunch of data, and that can take a bunch of forms. So we can have spectra, like what you see in the upper right, which happens to be a Raman spectrum from this cross-section. We may have data that takes the form of images, such as the copper, zinc, cobalt, chromium distribution map of the Manet that you see there in the center right. But any way you cut it, these tend to be, in today's world, digital files that I can store in that esoteric file system on my own computer. And so hopefully that gives you a clue that one way we could characterize these are as digital files or digital resources that are connected to the project. Typically, I would take all of this data, all of these images, all of the information that I learned, all of the interpretations of that data that I make, and I would try and write something down that collates all that information into some sort of final product. In this case, take the form of a publication of the exhibition. So it's a formal book. It may be an internal report for the institution. It may be both, which actually it is in this case, we have both. But in either case, what I've done is I've created a standalone textual material that talks about or includes the information from this project. So all of those might be components that you would need to be able to describe if you wanted to build a digital representation of this particular conservation project. But even as I talk through it, hopefully it's clear that it's not just those concepts that we need to be able to organize, but actually the relationships between them. So even talking through it, I felt obligated to say that this particular painting is part of a collection. I, as a person, am part of the Manet Research Group. The physical sample resulted from a sampling activity, right? And these relationships between things can get ever more complicated. So for example, we've identified that a person is an important project. And it's worth noting that in this particular case, there is a person, or several people actually, associated with the painting. We have the person of Manet, who painted it. We have the person of Jean de Marseille, which is the name of the historical figure who was the sitter. This is actually a portrait of a known person, Jean de Marseille. So we have that person that's associated with this physical thing. We talked about the relationship between, say, the whole painting and a sample removed from it. And so on and so on. Hopefully it becomes very clear that really there's tons of relationships between all of these components of a research project. And if we want to and fully describe the relationship or the project, the relationships that I'm trying to sort of indicate by all these red arrows are just as important as the components of the project themselves and have to be able to be recorded if we're going to create a digital surrogate of the overall conservation project. So to get a little more specific, that's actually what Arches for Science needs to be able to do. It needs to create a system to help us secure, retrieve, and visualize our data, but it needs to do it in a way in which all of those complex components of a project and all of the interrelationships between them are recorded and preserved over time. So that's the overall goal and what we're trying to build. Now, there are technologies that help allow this. One of them is what you heard about in the Arches presentation the other day. That is the use of sophisticated data models to code the data with what's known as semantic metadata that help make it self-describing. That is something that tells us that this physical thing is part of a collection or set. And that coding allows material to be ported from system to system, for example. And to better understand what that means, let's go back to this kind of seemingly simple example of a person. So hopefully you will take it at face value that I am a person that's speaking to you, right? And if I ask you to differentiate between myself and someone next to me, there's a lot of ways you could do that. But one of them would be by knowing that my name is Catherine, that I'm identified by the name Catherine. You could get even more specific if you wanted to and note that Catherine is my given name as opposed to another type of name like my family name or a pseudonym, for example. So one way to define me as a person is to say that I am a person identified by a name, by a type, given name, right? However, it's important to note that I have labeled this particular arrow that connects the concept of a person and the concept of a name by the phrase is identified by. But I could have labeled it with something else. Maybe you want to say that this person is, I don't know, related to Catherine rather than is identified as Catherine. And so you have to be really clear when you try and add this metadata to your underlying primary data, what you mean, what is the relationship you're trying to explain, and what are the concepts you're trying to connect. Standards, of course, can help with that, and one really commonly used one is the CDOC CRM, or the Conceptual Reference Model. And this is a system which describes in formal language the concepts and the relationships between them that might be relevant to cultural heritage data. Now, if all this, if we were to take the simple relationships you see on your screen then and encode them with the information in the CDOC CRM, we get something that functionally looks the same. We're still saying a person is identified with a name with a type, but now you see all these little number and letter codes that are sort of attached to that, which make it abundantly clear that we specifically mean person is identified by this name, and this name is an appellation. It adds all the definitions. Now, if that seems like a really fancy way to say that I have a name, it is, frankly, but it's a really important thing to do because it provides so much benefit. So I'm not going to read through everything on this slide. I'll let you read that while I talk at you, but basically what I want you to take away from this is that using something like the CDOC CRM to encode our data with this semantic metadata provides a foundation upon which other projects can grow, advancing the goals that you see listed here at the left side of the screen. So for example, projects like Linked Art make use of this to sort of create a specific community of users in the art space and identify terms that are important to those fields. And projects like Arches, and by extension, Arches for Science, can then make those things practical for someone to actually use it, like me, a conservation scientist, to use it by building tools that let me take advantage of those conceptual relationships. So as you can tell from the list on the left, there's a ton of benefits to doing this, and they're all critically important. I don't want to imply that any are more important than the others. But just coming from the perspective of a conservation scientist, I want to point out a couple in particular. One of those is sustainability. And so it's important to note that this concept of creating the metadata that makes it very clear what each component of this project is, makes the data self-describing and able to persist over systems over time, as long as the CDOC CRM is maintained. And that's really important to me because it means that any data I take today may be available and understandable critically to someone, many decades from now. And especially as technology becomes a bigger and bigger part of the data collection process, this becomes more important. I mean, how many of us have experienced taking data with a software system that, 10 years later, the company stops producing, so we can no longer read that data. Using a system like this corrects that problem and renders that data sustainable into the future. It also sets the foundation for a spirit of openness and community and data sharing because all of the data are rendered roughly the same way, right? We've all identified the parts of our data in the same manner, and that allows us to share it. And of course, sharing and communication is sort of the underpinning of conservation science and science writ large, actually. So what I want you to take away from this is that the reason we're interested in using this is because we see that conservation of the data that we take about objects in our care is itself part of conservation. By sharing that information, allowing people to make more and better or distinct interpretations about our objects based on data that exists, we hopefully make it easier to avoid taking new data in the future. For if we maintain that sustainability, maybe I don't need to go back and take another painting cross-section out of the Manet if I can re-access, reuse, reinterpret the section that already exists. Sustaining this data to us is part of conservation. Now, luckily at the Getty, using these kinds of semantic technologies is nothing new, as those of you that attended the Arches lecture will well know. I'm not going to go into too much detail about the Arches platform generally and how it meets our needs to build Arches for Science, but I do want to recap it just at a very high level. Arches has a series of features that make it really attractive. One is it's got robust data import and data management systems. It has many, many tools for data discovery and searching, including semantic searching, that is on those concepts that are designed with the semantic or designated with the semantic metadata. And it has the ability to build in comprehensive workflows to make the life of somebody using the system relatively straightforward. So there's a lot to like about Arches, and it's why we chose to build on that for Arches for Science. And again, just to hit the point home, part of that is the fact that it's built on standards like using the underlying CDOC CRM ontology, the fact that it uses controlled vocabularies like the Art and Architecture Thesaurus, and uses IIIF, or the International Image Interoperability Framework standards, to do cool things like annotate images. All of that is important in this realm of conservation science data because it means that my data will be, as we've discussed, protected through time and accessible into the future. So that's why we want to build on Arches. So from there, we're going to get even more detailed and specific, dive into what does Arches for Science actually look like. And to do that, we're going to stay with this concept of identifying a person. And show you what that really looks like in practice, as opposed to the sort of the little model of just the concept of a person, a name, and a name type. This is what it really looks like in person. If you take this concept of a person, you see listed here, and what I'm showing you here, I should note, is a data entry card for Arches and Arches for Science. And what you see in this blue column at the left are a bunch of the sort of concepts that you might be interested in recording for a person. So you say things like their name, their ethnicity, their nationality, their birth and death dates, gender. So there's a lot of things you could record about a person if you were entering them into the system. But if I play this little video, which I hope works, there we go, you can see that actually that's just the surface level. If we expand all of those categories, there's quite a lot more detail buried under there. This is all data that you could conceive of entering for a person. And rather than seeing 3 lines connected by arrows, this is what a visual representation of all of those connections actually looks like in what we call a data graph. So there's a really deep amount of information here that's much more complicated than what we looked at before. But what's really cool about that as a practitioner is, let's say we've entered a particular person of interest into the system already. So let's go back to this Manet painting that I studied. If we want to enter a new painting, Jean, the painting I studied, and say that it was painted by Edward Manet, if he's already in the system, I can just search for him, add him to the painting, and then what I get from that is all of this rich semantic information that's already been entered about Manet gets associated with my technical study of the painting Jean sort of for free or automatically. Of course, defining just the concept of a person, as we just discussed, isn't anywhere near enough to describe the full complexity of a conservation science project. And so in order to do this, we're creating data models that are just that complex or more, not just for the concept of person, but for many of the components that you need to adequately describe a conservation project, including some that we haven't talked about yet and won't talk about today in any kind of depth. But when all that is done, when all of those data models exist, what you get from it is a universe of connections that provides and shows all the linkages in a conservation project. So this is just a very small example, but hopefully you can kind of see that, for example, if we look at a painting from Manet, we can load all of the connections to that, to that artist. We can see that the painting was part of a collection of paintings that was studied. If we expand that collection, we see that there was a technical examination. And if we load more connections, you see this line form that tells you that I was the scientist that worked on that painting. So that's a very small example of just sort of one painting and some of its connections, and it's not even all of them. But hopefully it gives you enough that you can imagine what this would look like as this web of information becomes ever more rich as the system is used. Now, all that said, basically, there's a ton of complexity going on in this data, but that's what's happening kind of behind the scenes when the data is in the system, once it's been entered. So I want to kind of take a step back again and say, well, how did it get there in the first place? How did this data get entered? And do I, as the scientist using the system, do I need to understand all of that data complexity? And the short answer is I don't really. And that comes from the ability to use these workflows to define commonly used processes. So and again, you saw this in Arches, that workflows are a way to sort of describe the most commonly encountered processes that we might find. We're showing you just a small selection of possible workflows for a conservation process here. And these are kept as simple as possible for the user, as I said, hiding a lot of that complexity. And I hope that walking through a couple of these will make this a little more clear. And so we can, for example, come to the system and enter a new project. I've been asked to work on a new painting. I'm going to create a new project to define that. So how this would work is I would select that workflow and I would come to a screen that looks something like this, where we can see tabs like we're used to seeing in many interfaces and some data entry areas. And I can say, I can just type into this field that I'm working on the technical analysis of a particular painting. And I just want to note that this is just a text block. So you could name this in whatever way matches, for example, your institutional project naming conventions. There's also other pieces of data on this card. I'm just highlighting language, but I just want to note that basically each time you see one of these data entry screens, there's places where we're adding data that's building some of those complex connections behind the screen, or behind the scenes, pardon me. So if we've entered our project name and we click through to the next tab, we'd see something like this. This is called the project statement, and you again see a big open text box. And what this is actually designed to do is to actually allow us to record some of that information that we heard people talk about during the use case interviews as being important. That is, why was the analysis done? What were you trying to do? What were the goals? Because understanding that context may help someone understand why you have the data you have and how to interpret that data if they come to it later. And I want to note this one in particular because this is the kind of information that is very easily lost in institutional memory. If I leave the Getty, 10 years from now, is anyone going to know why I studied 32 Florentine objects? Is anyone going to know why it was important to look at 2 particular paintings from Manet? This allows us to actually record that information and make sure that it's not lost. I'm not going to talk about the next tab, which is project time span. You heard Dennis talk in the Arches presentation about the complexity of time, so we'll just let that lie. But I do want to talk about the next tab, which is adding the project team. So again, this is something that can easily be lost in a project history, remembering who worked on something. So we do have the ability to add that to a project. Here, how I did that was by starting to type my own name in the search box that you see here. And what you see pop up is, because the system has been pre-populated with people of interest, you see that 2 Catherines popped up. So I can select my name and then associate that with the project. However, one of the really cool things about this is, remember, all of this is built on that semantic metadata, which means you can also search on things like a concept. What does that mean? Well, in this case, it means, let's say somebody is entering this data for me. Maybe my manager is, or not my manager, but somebody's manager is entering a project into the system so that multiple people can work with it. And they can remember my first name, but not my surname. So they can't remember, is it Catherine L or Catherine P that's doing this work? Well, what they do remember is that the Catherine that worked on this project is a scientist, right? And so, for example, this person could start to write the word science in this search box. And what pops up is a list of people who are members of the GCI science department, because there's been this semantic linkage of these members as being part of a group that has the word science in its name. And in that process, they can say, oh, okay, so yeah, that was Catherine P. They can select that name and add me to the project. So that ability to search on a concept instead of just a search term can be critically helpful. And again, we won't walk through it, but you could do the same thing with, for example, adding objects of the study and things like that. And in so doing, create a new project in the system. So once you finish that, what comes next? Well, I've been talking about data this whole talk, so let's talk about how we would associate that with this project. So we could select the Upload Dataset tab, and we see a very similar workflow. And I want to start by noting one of the cool things that Arches does as a general principle, and that Arches for Science does specifically for conservation science, is it's been modified to refer or reflect the work we actually do. And that means that the first thing we do here is select one of the different types of data that are collected in a conservation science project. In this case, that kind of means sort of differentiating between the types of analyses we do in situ on the objects, so the images, the action images I showed you of me collecting data at the very beginning of this talk. And we can note that that is materially different from analyses where we might take a sample and do something destructive to that sample such that that material doesn't exist anymore. Semantically, those have very different connections behind them, so we can differentiate between them. So we do that, and then we go through screens that look very much like what you've seen before. We can do things like select the project that a coordinator just made for me on our last example. If there's a project like the Florence show that had 30 objects involved, I can specify which particular object in that research project are we uploading data for. Similarly, you can do the same thing with instruments. If your laboratory, all of the common instruments have been loaded in, you can select that. To upload a data set, that looks like something we've all seen in many different systems in the past. We can just drag and drop the relevant files onto the system and upload them. But then we come to another part that's really specifically tuned for conservation science. So one thing we haven't talked about is the ability to do image annotations such that we identify the areas of an object, in this case, a painting that you see here, as areas of interest or areas from which we did take data or make observations. But that's something we can do. We can select and annotate those areas and name them. So you can see here, for example, there are 2 named areas, one in the angel's face and one in the hand of a figure. And they're just called area 1 and 2. But once that exists, when we're in this data upload set, we have an extra ability, which means we can take each of those areas and look at the individual data files that we've just uploaded and select area 1, let's say the angel's face, and say that all 3 of these files that I've put a check mark on all came from that area. In this case, let's say an example where I used, this is X-ray fluorescence data. So I used a rhodium tube at 50 kilovolts driving voltage. I did it again at lower voltage to try and get a better understanding of the light elements. And I still wasn't happy with my data, so I did it again with a different tube, a chromium tube, to get a better view of, for example, whether there was any silicon in this area. But all three of those spectra fundamentally came from this angel's face. So we can actually say that in the system and link them together. Lastly, when you've done that, you can, as we heard in our use case interviews, people really want to be able to look at the data. So they've been busily building in lots of spectral viewers so that we can see that data. And actually, you can see here, we can enter specific file information. You know, if we want to say that I counted for 30 seconds to make this scan, we can enter that information here. And we can interpret it. I could look at this and say, well, here are the elements I see in this spectrum, and leave that information for the next scientist to come along. So hopefully it gives you a sense of what it would actually be like to use the system. So I just want to end by saying sort of what we're doing now. As I said, we're building out these data models, many of them for all of the different concepts that would be components of a conservation science project. We're continuing, along with the changes to ARCHES over time and the maintenance of that system, we're continuing to understand and develop new ways to visualize and search that data once it is entered into the system. And of course, we're continuing as we build out the data models and the ways of interacting with it. We're testing all of that with data from real projects. So that's the work that's kind of happening now and into the future. And with that, I think I'm at about the time that I was slotted to speak. So I want to stop. I'm just going to throw on the screen here the names of some of the people who've been really helpful with this project over the last several years. But other than that, we'll stop here and open the floor for discussion, and hopefully myself and Dennis can answer any questions that you may have.
Thank you very much, Catherine. While we open out these questions for everybody to comment on, Dennis, do you have something to say before we articulate the questions that people have put forward in the chat?
Thanks, Anupam. I'll just say that I thought Catherine did a great job. There's a lot there. Even a cursory glance will show you that she's thinking about lots and lots of information, working with sophisticated instruments, creating quite large data sets, and collaborating with lots and lots of people. So I think she really made a great case for how challenging the data management work is in the field of conservation science.
Thank you, Dennis. Catherine, we might need you to share the screen once again, because there are some requests to see some slides again. If you don't mind, do you think that would be okay with you?
For sure.
Thank you.
For sure.
One of those that they wanted to see was, one of the slides where you, in which you had the USPs.
Oops, sorry. I'm not sure what I'm sharing there.
Okay. It'll come. So Rizbe, you want to ask some question related to that slide also? Rizbe, please.
Nothing in particular. Just wanted to study what options are there, because I think unless we try it, we won't know it. That's for sure. But still, at least if we have a reference book in hand, we can try and see what chapters we are missing in the software, because it's quite an extensive.
Okay, we'll have a look at that slide once it comes on.
My whole screen has gone black, actually. I'm looking at nothing.
Yeah, it did. But in the meantime, while that is sorted out, Bhaskar, you want to articulate your question, please, yourself?
There we go.
Yeah, Yeah, thanks, Anupam. I specifically wanted to ask, whatever is the data, you spoke about data conservation. You opened a new channel there for me. Thank you. And that naturally led me to the question. Okay, so if you're talking about data conservation, in my understanding, is kind of generational. That's what we've been doing in the publishing industry, conserving data from HGML to XML to, and then to HTML to, and now to JSON and so on and so forth. So so this conservation is actually an industry and tends to be generational, is my experience. So what do you say about your data standard and its generational limitation and its capabilities, potential capabilities beyond it?
Catherine, do you want me to take that?
You can, yeah.
So this is an important question, and I think it's important to distinguish the format of the data versus the structure of the data, and we're making quite an important claim here, and it has less to do with the format of the data and more to do with including what Catherine has been calling the metadata, the descriptive information that's embedded in the way we structure data in Arches. And that is right back to the semantics. And it's why she talked about the semantics so carefully in her talk. It's the key idea here is that when you export data from Arches, you're not just exporting the values of the data. You're not just exporting the interpretation. You're actually exporting a data structure that includes the metadata that lets you as a person, and perhaps even more importantly, a computer, a machine, understand the context of the data, because we use semantics, and not just general semantics, but semantics tied to a specific standard, this so-called CDOC CRM. The intent is to make it much easier to interpret the context of the data and not just the value of the data. So it incorporates both the definition of the information and the information itself.
Yeah, thank you. Yeah. So you the meta and the content are both together all the time.
That's right.
Thank you.
Thank you, Bhaskar, for that intervention. Rizbe?
Yes, sir.
You had a question also. Would you like to articulate that question until we can get to that slide?
No.
Are you not seeing the slide?
We're seeing the first slide, the introductory slide.
Okay.
Okay. In this semantic linkage that you're talking about, can it be done by anyone? Means anyone can link anyone? Like, is this an IMDb kind of a scenario? If you've heard of IMDb, it's an open project. It's been taken over by Amazon, if I'm not wrong, and it's now a paid project now. And any actor can be linked to a movie he was acting in, or any director or spot boy. You know, any part of the movie industry can be linked to any, in that particular movie. So is this something like that? And because that can happen without permission, then somebody has to raise an objection and the moderator has to intervene, and so they have a role play over there, and a process of objection and this and that. So is this something, if we open the house, like the lady said, to everyone, it would be lovely. But if something like this happens, if somebody links a wrong Catherine to a wrong project or something like that, and off and on, how can so that's the question.
Yeah, say, Dennis, do you want that?
Sure, I'll take that. So again, there's, I think, two ideas that are kind of mixed together here. One is this idea of linking information, and the example of the linking actors to movies is that's actually I think that's a good analog. Arches has essentially the same idea at work, where when you use Arches for science, or really any Arches project, you in effect, you're doing this. You're making these linkages happen. So the example, I think, is a good one. The big difference here is that Arches has quite sophisticated data security protocols built into it, and it typically wouldn't be available to just anybody on the web. I mean, Catherine's been talking about Arches for Science specifically as a tool to help conservation scientists manage their data. And you have to have an account to even make any data entry possible in Arches. So you interact with the system based on the permissions that your account has been granted. And Arches supports quite granular level of data security. So you can allow some people, so everybody has to have an account to see it. Some accounts are only granted view status. You can only look at data and only select the data. Other accounts are granted the status of creating new data, including these relationships. So it really is a decision on the system administrator on who to allow access to the system in the first place and what kind of access they're granted. So hopefully that's an answer to the question.
Thank you.
And is this the slide that you were looking at, Rusbin?
No, sir. I think 3 slides to the right, maybe. That's the one.
The one that went back here. One more.
Previous to that.
One more back, or this is the one? Yeah. Okay. While the slide remains here for some time, Catherine, Juhi Bafna. Juhi, you want to articulate your question yourself, please?
Yeah, sure.
Yeah, you want to introduce yourself also, Juhi?
Yeah, hi, I'm a conservation architect. I work at the Center for Heritage Conservation at CEPT University, and we're mainly in the built heritage field. So I just wanted to ask whether the data for each entry can be downloadable into a report or a printable format to store or to disseminate or engage with physically.
Yeah, that's a good question. And the short answer is that's something we're working on right now. So it's clearly important to be able to communicate our results and share them with our clients, for lack of a better word. I'm very often working with a specific conservator or a specific curator, and I do want to be able to provide them written documentation, and as you say, to store documentation in written form as well for various institutional reasons. And so we're working towards finding ways to export certain critical pieces of information into report templates. And that's important to me as a practitioner, partially because it also, if we can automate parts of that process, that becomes something that doesn't take my time, right? And I can spend more of my time really digging into the details of a spectrum and analyzing it and letting the system, letting Arches for Science create the report from that for me. I don't know if you want to add to that at all, Dennis, but.
I think that's a nice summary, Catherine. I'll just say that Arches and therefore Arches for Science supports data export, but I think the question really here is a question about structuring data like a report and supporting download of that. And you're correct. This is the kind of thing we're working on really kind of as we speak. This is the topic of conversation with the development team right now.
So if this, sorry, if I may just continue. So if this code is open source, it can be worked upon, and developed by someone else and maybe proposed. Is that possible to engage with at the development level?
Yes, it's an excellent point, and it's correct. It is open source, which means that you are able to engage with the code and extend it or add to it, and we welcome that. We really are hopeful that people will take the code and adapt it to their use. And your only responsibility is to share your work with others. When if you do that, you're free to do that. Your only really responsibility is to make sure that you make your own code available for others to take advantage of your effort as well.
I think that's the thing of open source development, to have that community.
Exactly, that's exactly right.
Yeah. Thank you so much. Thank you.
But excellent. This is very nice, Dennis. It's very good. I think here in this CoSTAR program, when as it is talking about breaking silos and getting people to share things with each other and having a transdisciplinary sort of an exercise, this becomes an important part also.
Yeah.
There is, so in this context, I suppose it answers it in some way, but Anjali, you wanted to ask about access to arches. Would you like to say that? Would you like to ask your question?
Net is again unstable because of the winds today, so I'm having my video off. Thank you for the presentation. My only question was, I know that it was mentioned before that Disco is the part of basically a version of the customized version of the Arches software that has been made to use for Getty. And the other version is basically Arches for Science. So I'm just wondering whether either of the two are available for download on the Arches webpage itself, or is that something that we will have to customize at our own end? How does it work?
Shall I take that, Catherine?
Yeah, probably.
So I think this is also an important question, and this really kind of comes down to the distinction between Arches for Science and Disco. And fundamentally, they're essentially the same software with some configuration changes. So let me see if I can I'll try to make this as simple as I can. Catherine's working in a laboratory and with specific kind of art and specific kind of objects with specific instruments and with specific reporting requirements. And let's pick one example. The report, let's say Catherine decides that she likes a report with a particular template. Arches for Science will provide a template, but if Catherine decides that she wants to use a specific template and perhaps use a specific controlled vocabulary, those are configuration changes, and they represent the requirements, the specific requirements of the Getty. So when we do these very specific configurations, like choosing a particular controlled vocabulary to implement or to create a very specific kind of template, when we do that, we call those those configurations. We like to keep the configurations separate, and so that's the distinction between Arches for Science and Disco. Disco is Arches for Science, but with specific configuration decisions, like specific control vocabularies and specific templates. And so Arches for Science will be publicly available, and Arches and Disco will make the report templates available as well. You can use them if you want, or not. It's kind of up to you. But it's a very specific decision by a very specific Arches user. So hopefully that makes clear the distinction between Arches for Science and Disco and what distinguishes the two.
Thank you.
Anupam, you're muted.
Sorry, Akanksha asks that, are there any issues or problems like duplicate data that is generated by self-init or something, or that risk is not there? Or does one have to be conscious of it at all?
I'm not sure I understand the question. Could you repeat it, please?
Yeah, it says, okay, can we face problems like duplicate data being generated on its own? Or
So could you make two Catherine Pattersons, basically?
I can take that, Catherine, if you like.
Yeah.
So this is fundamentally a data structure and data validation question. And one of the things that Arches lets you do is define uniqueness rules. So you can implement rules in Arches that help preclude creating duplicate data. For example, you can apply a rule that says that the first name, the given name, and the family name of a person must be unique. That combination must be unique. You can make that rule. And if that's the case, then you can only have one Catherine Patterson in the system. But, you know, as unique as Catherine is, there might be other Catherine Pattersons in the world. So maybe that rule is overly restrictive. Instead, you might want to say the rule should be that the given name, the family name, and the role of a person in our organization needs to be unique. And so these kinds of rules can be implemented in Arches for Science so that you minimize the chance for duplicate data. But notice what I'm trying to say here, which is for every time you create a rule, there's an exception to the rule. So this is in some ways a sort of a philosophical question. What's a duplicate? What is a duplicate data point? I mean, I'm going to say that there are more than one person in the world named Catherine Patterson. So your DISCO data, your Arches for Science data set may well need to have two Catherine Pattersons in it. Are they truly duplicates? Well, there's only one Catherine Patterson who works at the Getty Conservation Institute. I've met her and I can tell you she's unique. So there's the distinction between the data and the thing you're describing.
Right.
So you just need to think carefully about uniqueness. It's a question that goes well beyond Arches.
But correct me if I'm wrong, Dennis, that is part of one of the things that can be customized, right? Is those rules.
Yeah, absolutely. You can, like I said, you can implement those rules in Arches, and you can make them as detailed as you wish.
Right.
So it's definitely possible. You are absolutely able to do this, but think carefully about what you mean by duplicate.
Yeah. And I would just add to that by saying that's kind of why I bothered to point out that, for example, things like naming the project, you might wish to implement the use of something like Arches for Science in such a way that it mirrors your existing institutional naming conventions, because presumably anyone for whom this is a problem has already had to think about it. You know, if you have two objects with the same name, you've had to find a way to differentiate those in your own records, right? So this can mirror that process.
Bhaskar, you want to say something?
No, fine, Anupam. In fact, that question can be skipped because the slide has answered it for me.
Okay. All right.
Thank you. Thank you.
Dhruv, you want to say something, Dhruv? Dhruv Chandra Sood.
Yeah, sorry. Hi. So I'm just wondering, firstly, if there are any other data management systems out there, and the one that comes to mind immediately is, of course, the Google Arts and Culture project. And so you've talked about duplication of data, and I'm wondering whether there's duplication of data management systems out there as well.
Well, that's really up to you to decide. Realistically, you know your data management requirements better than we do. So you can make the decision as to whether we're duplicating what Google offers or not. I mean, I would say that Arches for Science offers some very unique capabilities and also makes it really clear who owns the data.
Yeah.
You own your own data and you control who has access to your data in a way that you can be absolutely sure about. You also have control over how you describe your information in a way that I think is fairly unique. Like I'm sure there's a lot of data, there are a lot of data management systems out there. How many of them provide the same set of tools as Arches, I think is a relatively small universe of tools. And in fact, it may be that Arches is relatively unique in that category. I'll just say that if your question is, are there other options to Arches? The answer is very clearly yes, there are other options to Arches. And there may be options that are better suited to your needs. I don't know. You would know better than we would. But what we're trying to do with Arches is to ensure that you can describe your data, structure your data in a way that is specific to your needs, create data sets that will outlive the software because they're going to use semantic models that provide the metadata necessary for a person or a machine many years in the future to understand what your data are describing, and to provide tools to make it easy for you to interact with the data and share with your colleagues. So I would say that's a pretty ambitious goal. And if you're aware of other software that does that, it'd be great for you to share that with us, because I think we'd be very interested in seeing how they're doing it.
And I think part of the reason that we wanted to build Arches for Science is because while there are a lot of things out there, I think the other thing to really keep in mind is the audience for the different types of data. And so, yes, there are industrial softwares that chemical laboratories the world over use to hold spectral data, for example. But those softwares in general don't have a way of linking that to a physical location on something like a physical object, something like a painting, right? The Google Arts and Culture stuff privileges the types of information that we make public. You know, they're not geared towards some of the data that you or your institution might be hesitant to share. And so it's really, it's something that we're building to deal with a very particular nexus of needs for the control, as Dennis said, of that information, and to be able to met it out to particular users.
Just to follow up to that, if I might ask, is it possible for data management systems to interface with each other?
Definitely. And so, for example, at the Getty, we use TMS to manage our collection data, right? And there's always ways to, for example, allow Arches for Science to draw from TMS as a source of data, right? So that I don't have to individually enter all of the objects of our collection. Dennis, do you want to expand on that?
Yeah, there are ways for data to flow between different software systems. And I mean, Catherine gives a really good example that museums will typically have software to manage their collections, and the objects that we study with Arches for Science ideally would draw from those collections management systems. And in fact, we can do that. There's a thing called an API, an application programming interface, that allows developers to transmit data from one system to another in a secure way. And Arches is capable of both using another system's API to request data from it, and it also has its own API to allow other systems to request data from Arches. And we could have a whole conversation about how this actually works in practice. Let me just say that these programming interfaces are designed to share information, and some can be quite sophisticated. Like in the case of Arches, you can use an external system to request data from Arches. You can also use an external system to provide data to Arches programmatically. In other words, automate the sharing of information from one system to the other. Automate ingesting information from one system into Arches and automating the sharing of data from Arches into another system. That's quite possible.
And it is really important in the practical use of the system. For example, so if the museum acquires a new object, that sort of automated ingestion from the collection management system would mean that that object is available for me to create a project around in Arches for science, for example. You're muted again.
Thank you.
I have one thing to make, statement to make. So there is a group of 100 here, of us who are processing what you are saying, and according to our own capacities of taking it in or understanding it, and our own experiences, and our possibilities of being able to take it further. That's also there, either individually or as collaborators. Now, from your point of view, having invested your time and having the grace to also share your experience with us, what do you see for this audience, for this motley crowd, so to speak? What do you see as various ways in which you would perhaps, if not expect, but in ways in which you would perhaps like to see that different members or different groups here could engage with what you are presenting to us?
Sure. I think the easiest way to talk about that is to go back to what I was kind of saying is what I kind of hope as one of the fundamental takeaways of this presentation and of the Arches presentation before this is this concept that the data we produce about our works of cultural patrimony are important, and we shouldn't think of them as transient or things that it's okay if they get lost on someone's desk or just become inaccessible. And so if you take that as a sort of fundamental building block, depending on where you, as you say, as an individual or you as an organization are, hopefully this starts to inspire people to start to think about data management and data organization as a fundamental part of the work we do, regardless of your job description, whether you're a scientist, a conservator, a project, or a site manager. Conserving data should be part of your job description. For people who are in positions of sort of, directing staff at a museum, for example, maybe you want to start thinking about, is there actually a need for somebody in our organization whose role is to help with data management? So that whenever your organization gets to the point where they are ready and able to implement something like Arches for Science, you have the sort of mental picture of what you're doing and why in place. And then, of course, if you're ready to implement now, that's a whole different ballgame. But regardless of where you are sort of in that process, I would say figuring out what data management needs you have and how to sort of advance that as a process.
Excellent. Thank you so much. Thank you so much. There were two hands. We have 5 minutes for the 90 minutes to close. Srishti, would you like to go first and then the second hand?
Yeah, sure. Hi, Catherine. Thank you so much for the presentation. So I was just wondering, we were talking about the many specimen, right? And finally, we reached that one slide that had all of those linkages drawn. I definitely understood what you were trying to say, but I was trying to read it and your audio got cut somewhere in between. So I was wondering if you could just show that slide once more.
The one with those red arrows?
Red arrows.
Yeah. Yeah.
Back a little bit.
Background in the meantime?
Yeah, this one. Yeah. The anatomy finally when the arrows are here. Yeah, I just missed that last part, so I wanted to have a look at it once. That's it.
Yeah. And I should note, this is just sort of a quick visualization of the process, but hopefully what you take away from it is that there are many ways to categorize a project. This is a quick look into how we are currently doing that. But
yeah,
it's not the only way one could. I'll say that.
Definitely.
Shrishti, what's your background, Shrishti?
So I'm an architect myself, but I'm working with an organization. It's a social history collective, where we're working with artisans of different communities who are working with materials like oxide and artisanal handmade tiles and things like that. So I'm primarily an architect. But another thing that the organization has been doing for the last decade almost is household heritage and personal history. So we're looking at conservation and exhibits of objects at home that speak more about intangible heritage than they do about tangible heritage in that sense. So that's the realm in which I've been working for the last 2 years.
Yeah, and you can imagine if you were to try and sort of do the same kind of visual graphing out of what a project around intangible heritage looks like, you're going to end up with different categories.
Definitely, yeah.
And so I think that comes back to something that I know Dennis said during his talk, and that hopefully I remember to say, is it's really important whenever undertaking any kind of project like this to be really introspective about what is the important data to track for your kind of project, right? And recognize that it's going to be different for different organizations, for different types of projects. You know, there isn't one answer or one solution for everybody. And so that's a huge part of the work. And that's why I say kind of coming to that sort of understanding as an organization as to what are your data management needs? What is the information that you need to be able to carry into the future is a huge part of the work. And it really can't be understated how important that is.
Yeah, I think especially when you were talking about that space to, you know, record a statement as to why you chose to do a certain project, a parameter equivalent to that would be something of great importance in this case, especially if, say, I'm going to record intangible heritage or an account of intangible heritage, if I may put it that way, then those are the things that become, or those are the data inputs that become more important to us later on if we were to carry the study forward, right?
Absolutely. And it's worth noting, this is also the importance, or one of the reasons that it's important to use standards. So things like the CDOC CRM has categories for things that are more intangible. So you can talk about more sort of esoteric concepts like the information content in something. So you, if you're doing personal histories, if you're trying to capture, you know, what's important about a story that's told through an indigenous group of people over time, but that's not written down anywhere. You know, there are components of the CDOC CRM that deal with some of those things. So again, it's just you have to be able to define that.
Yes, thank you.
Thank you very much for that. Thank you. Thank you, Catherine. Thank you, Dennis. Would you like to say some words to us before I conclude the session?
Oh, thanks, Anupam. I feel like Catherine's done a great job today, and I don't have anything to add.
Catherine, anything from your side? Just something for the group that is here?
I would just say enjoy playing with your data. Know that, you know, even like that, this is something that all of us are struggling with and still working our way through. So it's going to take all of us a while, but hopefully we all get there together.
And if I may ask, Alison, are you here with us?
Yes, I am.
Alison.
Oh, hi, Alison.
Yeah, hi, Alison. Thank you so much, Alison. Though you did not speak on the first day, but we've been, we really thank you very much, you know, for helming all of this and we're very grateful for the support, for graciously having your team with us. Would you like to say something to us before I ask Nina to conclude the session on behalf of CoSTAR?
Well, I'd just like to thank everybody for spending your time with us and listening to what we think is a fantastic project, and we're always happy to talk about arches. And I think Catherine did a great job today, and Dennis, as usual. And if you have any questions, just please let us know. We're very passionate about our work, and we're always willing to share and help support others who are interested. So thank you.
Thank you so much. Thank you. Thank you very, very much. Thank you, Alison. Thank you, Alison. Nina, may I request you to please talk to us for a little bit?
Well, I'm just so grateful to the Getty Conservation Institute. You've, generously shared so much information with us. And Alison, I was also just looking in the chat that you were saying that all of your information, whether it's arches or disco, it's open source. And so I think what Anupam had asked is an important question. And this is to all our participants and to the organizations you represent or work with, is for us to continue to think together that how we can engage with what we have heard in these last, I think it's been two different, the public talk as well, that how can we engage with what Getty has exposed and shared with us. And if it is an internal cost of setting up a system or infrastructure, which is something you're already doing, then I think the question we have to ask ourselves is how can we pool our resources and make it more efficient? And I think that's something that I have taken away from these two lectures. And Anupam, I hope that we and all of you participants, we can put our heads together and think about what we can do in India and for the work you're doing. So my sincere thanks to all of you again for actively participating. Over to you, Anupam.
Anupam, on mute one more time. Oop.
Yep. No, sorry about that. But thank you very much, ladies and gentlemen. This has been really, really good. This has been, it's been very enabling. And thank you, Alison. Thank you, Catherine and Dennis. And please convey our regards to Tim Whalen and Jim there at the Getty. And we're very grateful, and we are all aware of the support Getty has provided to everybody around the world. And we are one group in that. Thank you so much. Very grateful. Thank you.
Thank you all for having us.
Thank you.
Have a great night, everyone.
Thanks,
Thank
everyone.
you very much. Thank you.
Bye.
Thank you, Simon.
Bye.
And Chelsea and Megan. Thank you so much. And ladies and gentlemen, thank you for joining us. We see you again very soon. Thank you.